In this final video of the packet injection series, I'll teach you how to inject ARP reply packets into the network. Now the unique thing about this example is going to be that instead of relying upon the header files for the packet header structures of Ethernet and ARP, we will define our own headers in the program and use them to send out the packet onto the network. So starting off with the code, the usual includes, then we have the source Ethernet address of the packet, the destination Ethernet address of the packet, the source IP and the destination IP. Now after that, you would notice that we have defined a structure of type called Ethernet header, which is an exact replica of the Ethernet header in Linux if_ether.h. First we have the destination address for 6 bytes, then we have the source address for 6 bytes, and finally the protocol of 2 bytes. And then after this we go ahead and define the ARP header. First of course the hardware type, then the protocol type, the hardware address length, protocol address length, the op code, whether it's a request or a reply, the source hardware address, source IP, destination hardware, destination IP. So if you notice, this is almost exactly a replica of the headers defined in the include files, but we have basically redefined them, given them better member names so that we can use it. The point in doing this exercise is to make you understand that if you want to design your own custom protocols which might have custom headers, then you can do it by defining those headers in such a fashion. Now moving on, see some familiar code here: create raw socket and the bind raw socket to interface functions, which are the same as in the previous examples, and so is the send raw packet. Then we have the create Ethernet header. Now this function is identical to the functions which we have seen in the previous examples. The only difference here is that instead of defining a struct ETH header, we are defining an Ethernet header which we have already described in the above lines of code. Now we go ahead and copy the source MAC address exactly the way we would do it in the previous cases, as well as the destination MAC address and the protocol. Exactly the same, only the members change because now we are using a different sort of a header. Now we go ahead and create the ARP header. Once again, as the ARP header shown here in this example is a clone of the ARP header defined in the Linux include files, we can easily follow on an element by element basis with that header and this header. So here we are filling up all the details. The hardware type we fill it up as basically Ethernet. Then after that the protocol type we say it's IP. Hardware address length of course is 6. Protocol address length, which is IP, is 4. That's how long the IP address is. The op code we put it as a reply, ARP reply. The source hardware is basically taken from the above hash defined source ether ADDR. In this step we actually convert the source IP from ASCII format to binary format and store it in the variable temp. In the very next step we copy this onto the ARP headers source_IP member. Similarly we do the same for the destination_IP here, and of course the destination hardware is copied from destination_ether_ADDR. we convert it to network byte order and then store it in the dest_hardware member. Now moving on to main, once again everything must look familiar. We create the raw socket, we bind the raw socket to the interface. Now we create the Ethernet header and then we go ahead and create the ARP header. Then we find the packet length, which is nothing but size of the Ethernet header and the ARP header put together. We allocate memory for such a packet because now we have to basically combine both the headers. First we copy the Ethernet header to the beginning of this packet, then we copy the ARP header but only after the Ethernet header. This is encapsulated in this part of the code. After doing this, we simply send the packet out, send raw packet. Then we go ahead and free the various headers which we created, and then we close the raw socket. So as you can see, this is identical to whatever we've been doing before, the only difference being that instead of using the ready-made definitions of the header present in the Linux include files, we have created our own definitions of the header, and that is all. There is nothing complicated in it at all. You can define the headers. Of course, they have to basically be, the members would have to be of identical size as the Linux headers itself and in that order, but you can name them as you want. So as we remember that the Ethernet header was called struct eth-hdr, and the first member was h_dest, second was h_source. So these names were not very descriptive. Now we have more descriptive names such as destination source. But actually the real power of defining our own headers lies in the fact that you can define your own new protocols and communicate between two such machines who understand these protocols. Now let's go ahead and compile this piece of code. Let's start off our sniffer. We remember the source address to be all A's, and we only want to consider ARP packets, so we can start listening here, and then we can run this code. Before that, let's also set up Ethereal and put the filter as ARP. Now we go ahead and run this code. Packet was sent successfully. If we look at Ethereal, then we can see that packet, right? As you can see clearly, this is an ARP packet sent by 192.168.0.10. that is the source IP which we mentioned, and here is the actual header, right? Source MAC all A's, destination MAC all B's, protocol is ARP, and it's an ARP reply as we had framed in the packet. The source MAC is all A's, source IP is 192.168.0.10, target MAC is all B's, and target IP is 0.11. So we have succeeded in sending an ARP reply packet onto the network using raw packet injection. Also, our TCP dump gives us a more textual view of the same packet being sent out on the network. It's an ARP reply. It was sent by 192.168.0.10, saying that it is available at the all A MAC address. Of course, the manufacturer cannot be found, and it says OUI unknown. And this is the hex dump of the packet. So with this we conclude our packet injection tutorial series. I would advise you to practice many of these examples as many times as you can, and also play along by modifying various fields and rewrite the whole code yourself. That's it. See you in a later section. Thank you.